Hi, today we're going to go through a PAT paper from 2009 looking at question 3. Okay, so in question 3, we're asked to find the equations of the two lines that pass through the point 0,4 that are tangent to the circle centered at the origin of radius 2. Okay, so let's start by sketching this. It makes it a lot easier to visualize. So if we just sketch an x and y axis, we'll extend that a little further down, and we'll draw a circle of center of radius 2 first of all. So let's just, here's an attempt at a circle of radius 2 centered at the origin. And then we'll have our point somewhere up here, and that's 0, 4. And we'll have that has two lines extending from it that are both tangent to this circle. Okay, and as always, we know that the radius meets the tangent at 90 degrees, and we know that's a radius 2. And let's say we call this angle here theta. Okay, right, well now what? We need to find somehow another point that these lines pass through so we can find their gradient. And well, one point that might be useful to consider would be the point where it is tangent to the circle. Right, how can we find that? How can we use that? Well, let's start by creating another triangle. It's always a good way to start. And we'll just label this point A, B. So we can find AB, we can find the gradient of the line, and therefore find the equation of the line. So what do we know about this? Well, we know this side length here is of side length 4, because that's at coordinates 0, 4 and 0, 0. And we've said this is AB. So that means that the base length is A, the x coordinate, and well, this is B. Okay, what else can we label on? Well, we know that the angle here, theta, is the same as this angle here, theta, because we have two parallel lines, so we can label that on. And we also know that, well, this angle here is 90 minus theta, so this angle here is theta. So we have another theta up here. Okay, well now we can read off that, well, we know we have a right angle triangle, and we have an angle theta, and we have side lengths. So let's look at this one here. We have sine theta would be equal to b over 2. Okay, so sine, oh, what happened there? Sine theta is equal to b over 2. And that comes from this small triangle here. We have the opposite side, the adjacent, the hypotenuse, and the angle. Well, clearly, we can't have b being 0, because that would mean that theta is 90 degrees, theta is pi or 0, and theta is neither of those values. And we can't have b being greater than 1, otherwise you have sine theta being greater than 1, so that's impossible. So, we can't have b being 2, because if b is 2, that means that sine theta is 1, i.e. theta is 90 degrees, and again, that's not the case. So that means b, what's happening here? B must be 1. Okay, well how can we find A? Well, we have a right angled triangle here and here. And we know the hypotenuse of this triangle is 2. We know this is 1, so we can just use the Pythagoras theorem. So we know a squared plus b squared equals 2 squared, 4. We know b is 1, so that means a squared is equal to 4 minus 1, or 3. And therefore a is equal to root 3. Okay, well now we have another point. So let's find the gradient. So the gradient of our line will call us 1 and 2. The gradient of 1 will be equal to the change in y. So that's going from from b, which is 1, up to 4. So that's change in y of 4 minus 1, over a change in x, which is going to be going from, well, we went from this point to this point, so we're going from here to here. So that's b at a, root 3, minus 0. So that's root 3. But remembering it has to be minus root 3, because we've considered the direction from this point to this point. So we went from here to here, so that's root 3 to 0, and then from 1 to 4. So that's minus root 3, up 3. So that gives us a gradient m1 of 3 over root 3, 3 over minus root 3, or simply minus root 3. And you can tell from the symmetry of the graph that this line is going to have exactly the same gradient as the other line, but the positive of it, because they're going to be inclined at the same angle, because this angle here will be the same as this angle here, so this will be the same as this, so they're going to have the same gradient, but it'll be positive. So that means that M2 will in fact be equal to root 3. Okay, well they both pass through 0, 4, so you can simply say the y-intercept is 4, therefore we have y1 is minus root 3x plus 4, and y2 equals to root 3x plus 4. And that's our answer.